Welcome to the Deep Dive. We're the show where we take a fascinating subject, dig into the research, and pull out the key insights for you. Basically, your shortcut to getting well informed.
Yeah, exactly. And today we're heading way, way back in time. We're exploring a really intriguing dinosaur called Amtocephale.
Right. And we're working from essentially the scientific lowdown on it, the initial report.
Pretty much. We're looking at a scientific overview, how it was discovered, where it fits in the dinosaur family tree, and, what it tells us about how these animals evolved.
Okay. So our mission today is to figure out what this specific discovery, Amtocephale, what it reveals about the history of dinosaurs, especially those famous bone-headed ones, the pachycephalosaurs.
Mm-hmm. The ones with the incredible headgear.
Exactly. All right, let's dive in.
Yeah.
Where exactly did this fossil show up?
Okay, so Amtocephale comes from the southern Gobi Desert in Mongolia.
Ah, the Gobi. Classic dinosaur territory.
Absolutely.
Yeah.
And the specific spot is called the Amtocephale site. It's part of a bigger rock layer, the Baincher Formation. You'd sort of picture these vast ancient landscapes.
Definitely paints a picture. So how did the paleontologists actually zero in on this spot? Was it just luck?
Well, not quite luck, more like years of hard work. Starting way back in 1993, there were these joint expeditions. The Hayashibara Museum of Natural Sciences from Japan and the Mongolian Paleontological Center.
Okay.
They began systematically searching the Gobi. And it was during digs at this Amtocephale site over several field seasons, actually 93, 94, 2001, 2004, that the Amtocephale fossil finally came to light.
Wow, that's some serious dedication over many years.
Really, yes. Persistence pays off in paleontology.
No kidding. And the name, Amtocephale, it sounds quite specific.
It is. The genus name, Amtocephale, is a direct nod to the discovery location. It combines Amtocephale, the site, with the Greek word kephale,
Which means...
head.
Ah, makes sense. Amtocephale, head.
Exactly. And the species name, Gobiensis, that's pretty straightforward, just refers to the Gobi Desert. So, yeah, Amtocephale head from the Gobi.
Nice and descriptive. Okay, so who were the scientists that officially put this name on the map?
Amtocephale was formally named and described back in 2011. It was a team effort by Mahito Watabe, Kishijat Sakbatar, and Robert M. Sullivan.
Got it. Watabe, Batar, and Sullivan. And what was the actual fossil, the key piece of evidence?
The K piece is what we call the holotype. That's like the definitive example of the species. Its catalog number is MPCD 1701203.
And what is it? A tooth, a leg bone,
It's a skull fragment, specifically a nearly complete frontoparietal dome.
the bony helmet part.
Exactly.
Yeah.
That fused bone structure on the top of the skull. And importantly, this one belonged to a subadult.
Oh, so not even fully grown.
Correct. Which
It-
is
it-
something to keep in mind when we talk about its features.
Right. Okay, so we know where, when, and who. Let's place it on the big family tree. How does Amtocephale fit into the whole classification system?
All right. So zooming out, it's in the domain Eukaryota, kingdom Animalia, phylum Chordata. Then we get to the clade Dinosauria.
The main dinosaur group?
Yeah. Then within that, it's in the Ornithischia. That's the bird-hipped dinosaurs. And then more specifically, the Pachycephalosauria clade,
The boneheads we mentioned.
the very same. Then it gets more specific. Family Pachycephalosauridae, subfamily Pachycephalosauridae, and finally our genus Amtocephale and species Amtocephale gobiensis. Quite a chain.
It is. And maybe just quickly for listeners, what does clade and family mean in this context? Just a quick refresher.
Sure thing. Think of a clade like a branch on the evolutionary tree. It's a group that includes a common ancestor and all its descendants, everything stemming from that point.
Okay.
A family is a bit more specific, usually nested within a larger clade. It groups together general like Amtocephale that share, more recent common ancestors, a bunch of distinct traits. So Pachycephalosauridae is the immediate family of these closely related boneheads.
Got it. Clade is the big branch. Family is a tighter grouping on that branch. So Amtocephale is definitely in the bonehead club. Now, why is this discovery considered so important? This is where it gets interesting, right? The age.
You got it. The age is really the kicker here. The Baincher Formation, where they found it, well, dating it precisely has been a bit tricky.
Oh, how so?
Initially, it was sort of broadly placed in the early part of the late Cretaceous. Think Cenomanian to Santonian stages. That's roughly 95 down to maybe 83 million years ago, pretty wide window.
Right.
There was even talk of calling it a unique Baincherian age because the fossils found there seemed quite distinct.
A whole new geological age. Wow, that does suggest something special.
Exactly. And based on other fossils found nearby, like certain plant-eating dinosaurs, ornithopods, and that weird theropod Signosaurus. The thinking was the Amt site probably wasn't younger than the Santonian, so older than about 83.5 million years,
Yeah.
possibly quite a bit older. They even compared the mix of animals to stuff found in the Milk River Formation up in Alberta, Canada, hinting at a similar sort of time frame.
So a general ballpark age, but not super precise at first.
Pretty much. But then, more recently, things got a lot clearer. In 2020, some researchers, Kurumada and colleagues, used a technique called calcite UP dating. It's a radiometric method, much more precise.
Uranium-lead dating on calcite. Interesting.
Yeah, and their results narrowed down the age of the Bainshire Formation significantly. They estimated between roughly 96 million years ago, plus or minus 6 million, and about 90 million years ago, plus or minus 4 million.
Okay, so that tightens it up considerably. Cenomanian into the coniation stages.
Exactly.
Mhm.
And this is the key bit for Amtocephale.
Right. How does this new, tighter time frame change its status?
Well, it strongly suggests that Amtocephale could be the oldest known pachycephalosaurid, or at least one of the very oldest.
In the oldest? Wow.
Depending on where the formation's true age lies within that refined window.
Yeah.
It potentially pushes back the origins of this whole group of bone-headed dinosaurs significantly.
So this find from Mongolia might actually represent one of the earliest members of this lineage. That is a major aha moment.
It really is. It points towards an earlier start for these guys than maybe we thought.
Okay, fascinating. So let's zoom back in on the actual fossil, the holotype dome. What can it tell us about what Amtocephale looked like?
Well, we know it's that fused frontoparietal bone structure. The preserved part is about 53 millimeters long.
Just over 2 inches.
Yep. And its maximum thickness is around 19 millimeters.
So 3/4 of an inch thick.
About that.
Which, considering it's from a subadult, maybe isn't the super thick battering ram we sometimes picture for later pachycephalosaurs.
That's a good point. It wasn't fully mature. But what's really interesting, anatomically speaking, is how much of that dome length is made up by the parietal bones, the ones at the back.
Oh, how much?
About 41%, which is described as unusually large.
Why is that significant? Does that differ from later ones?
Well, yeah. While we don't have direct comparisons right here in this source, highlighting that large parietal contribution suggests its dome structure might have been, proportioned differently than some of the later, more famous pachycephalosaurs.
So the way the dome was built was maybe different in these early forms.
Potentially, yes. It hints that the classic thick dome might have evolved over time, perhaps with different bones contributing more or less as the group developed. Maybe early versions weren't quite the same shape or structure.
That's really cool. Getting clues about evolution just from the proportions of one bone fragment.
Okay, let's widen the lens again. What does finding Amtocephale in the Gobi tell us, big picture, about where these dinosaurs lived?
Well, it definitely adds to our map of pachycephalosaur distribution in the late Cretaceous. We often associate them heavily with North America and later discoveries in Asia. Finding such an early potential member in Mongolia suggests the group might have had a wider, maybe an earlier presence across Asia than we fully appreciated. So they weren't just limited to certain spots early on.
Seems like they might have been more widespread earlier than we knew. And the Bainshire Formation itself, it's clearly a hot spot for fossils, isn't it?
Sounds like it. What else has turned up there?
Oh, absolutely. That Amt site specifically has given up a real mix of Cretaceous critters. Besides Amtocephale, they've found vertebrae and limb bones from various ornithopods.
Plant eaters.
Yep. Plus turtle skulls and shells and even multiple specimens of that rather unique theropod, Signosaurus.
So a whole ecosystem frozen in time.
Pretty much. It paints a picture of the world Solidos. Amtocephale live in diverse, full of different kinds of dinosaurs and other reptiles. It gives us context.
Right. Okay, so let's sort of wrap up the key points from this deep dive on Amtocephale. We've learned it's a pachycephalosaur from Mongolia, and crucially, it might be the oldest or one of the oldest members of that family found so far.
Correct, thanks to that more recent dating of the Bainshire Formation.
And its head dome, at least based on the subadult holotype, had this notably large parietal section, hinting at maybe some evolutionary changes in dome structure over time.
Exactly. It's like a snapshot from an early chapter in pachycephalosaur history. A really important piece of the puzzle, suggesting the group might have started earlier or perhaps in a different area than we previously thought.
Which leaves us, and you listening, with a really interesting thought to chew on. Given that Amtocephale is potentially so early, and the specimen we have is a subadult with maybe a less extreme dome, What was the initial purpose of that thickened skull? Were these very early pachycephalosaurs already headbutting?
Or did that structure serve a different function initially, maybe for display or species recognition?
Exactly. It makes you wonder if the famous headbutting behavior was there from the start, or if it evolved later from a structure that originally served another purpose.
That's a fantastic question. The relatively modest dome size here compared to, say, Pachycephalosaurus itself certainly keeps that possibility open.
Hmm.
It wasn't necessarily for full-on combat right away.
It's a great reminder that evolution is complex and features can change function over time, and just makes you wonder what else is waiting out there in the Gobi.
Who knows what the next discovery will reveal? It's an ongoing story.
Absolutely. Well, thanks for joining us on this deep dive into the world of Amtocephale.